the first question here is that given that the universal set U is equals to 1, 2, 3, A, B, C, D, and a set A is 1, 2, AD, and a set B is 2, 3, CD. Okay, those are the elements of the set, that you should find B backslash of A intersecting with A union B. So, by these notations, we are just going to make use of their definitions, and we are going to go ahead and answer the question. Now, B backslash A simply is a simple notation that stands to tell you that you should take away the common element of the set B and the set A from the set B. That is, if there are common elements between set B and set A here, then take away those common elements from the set B, so the remaining is B backslash A. So in other words, it means the elements that belongs to B but does not belong to A. So we will compute B backslash A to be elements that are found in B, but we exclude elements that are found in A from elements that are in B. So we look at the set B, it is 2, 3, CD. We look at the set A, 1, 2, AD. So the question now is, which elements of the set A are in this set B? Okay, which elements of the set A are in the set B? Set A has 1 is not here. Okay, we see 2 in set B, and that same 2 repeats in set A. So 2 is not going to be the element of B backslash A. So the first element that didn't occur, okay, so the first element here occurs in A, so it will not be a member of this new set. Now the next element is 3. 3 is in B, but 3 is not in A, so that will be in the new set. The next one is C. C is in B, but C is not in A, so that holds, right? The next one is D. So D is in B, and D is in A, so we are not going to take D, because by B backslash A, we are talking about elements that are in B only, but not in A, alright? Okay, another notation for this B backslash A is also B minus A. They are the same thing. Alright, so the next thing we are going to consider is A union B, which is given to be the union of those two sets. So we're just going to take all the elements, that will be 1. Let me list them. 2, 3, A, C, D. Okay, so those are the elements for A union B. So the intersection of the two sets now, talk about B backslash A intersecting with A union B. This is going to give us, well, we'll go ahead and look at this. 3 is here and 3 is here, C is here and C is here. So the intersection is just C, 3C, right? And 3C is the same thing as B backslash A. Okay, so that ends. This is the result that you get for the first question. So let me just put down the second question quickly. Okay, so we go ahead with the second question. We have it that to obtain the interval for which this inequality will be satisfied, so we have it that 1 over x plus 1 should be greater than 1 over 2x minus 3. Okay, so obtain the interval of x for which this is going to be satisfied. Now it will be, okay, let me just start like this, x plus 1, then minus 1 over 2x minus 3 greater than 0. Okay, so I'm just subtracting the expression on the right hand of the inequality from both sides. Okay, so the next thing I would like to do is to go ahead and multiply, take the LCM, okay, of this, and from there we're going to have, just by multiplying this with this, and then multiplying the denominators, so I'll be having 2x minus 3 minus x plus 1 divided by x plus 1 times 2x minus 3, and that is still greater than 0. Okay? Now from here, we'll just go ahead and simplify everything on top. We're going to have 2x minus x, that is just x, and then negative 3 minus 1, that is just, okay? So negative 3 minus 1 is going to give us negative 4, right? So we just put it down, negative 4. Then divided by x plus 1 and 2x minus 3 greater than 0. Okay. Now when we reach a point, this point, and luckily enough, the numerator and in the denominators, all the terms are like factors. Okay, then the next thing we like to do is to do some testing. Now, we know that this inequality should be greater than 0. That means it should not be equal to 0, neither should it be less than 0, but it should be greater than 0. Now, for this inequality to be equal to 0, that is to become an equation, x minus 4 will be equal to 0. So if the numerator here is going to be 0, that means we are going to get the whole expression equal to 0. You know, the numerator of a fraction, if it is 0, everything will just be 0. So the numerator should not be 0. So we are looking for the value of x that will make the numerator to be 0. So we would exclude that value, alright? Then, the next thing is in the denominator. The denominator should not be 0 in any fraction. So we also equate this one, the product of these two factors, to 0. You know, the product of two terms to give you 0, one of them could be 0. At least one of them could be 0. So this follows that x plus 1 can be 0 or 2x minus 3 can be 0. So we are going to solve each of these equations and take out those values that will make this thing to be undefined, and we are going to use those values to get the interval, okay, that inequality will be satisfied. So from the first equation here, we have that x is equal to 4. From the second equation, we have that x is equal to negative 1. And from the third equation, we have that x, you know, if you make x subject of formula here, you're just going to have 3 over 2. Alright? Okay, so this is how we are going to make use of those values. I'm going to go ahead and draw a line, okay, a real line. Then I'm going to mark out the point that I've just taken. The first one is negative 1. The second one will be 3 over 2. And the next one will be 4. So those are the 3 points that I've considered there. Now, we know that before the negative 1, we consider the negative numbers, okay? Moving to negative infinity, and we'll consider the positive numbers towards positive infinity, alright? And if we pick any number from this interval, and we put it back into the original inequality, okay, let me use this one. If it satisfies the inequality, that means that that number or that interval in which the number is being picked from is one of the intervals that will make that inequality to be satisfied. So for example, I'm going to pick negative 2 because negative 2 falls here. So if I put negative 2 inside here, we're going to have negative 2 for x. That will be negative 6 on top. Okay, so let me just do some working. Negative 6. Then on the bottom, we'll be putting negative 2 plus 1. That will be negative 1 times negative 2 here. That will be negative 2 times negative 2. That's negative 4 minus 3. That will be negative 7. Alright? Now, look at this. The product of these two numbers will give us, at the top we have negative 6, and at the bottom we just have positive 7. So we're having negative 6 divided by 7. That is less than 0. Okay? It is not greater than 0. So this part does not satisfy. We mark X. That means it does not satisfy what you want. Alright? Now the next thing we'll be considering is from between negative 1 and 3 over 2. We can see 0 will be there. So you put 0 here. The inequality I was making use of this one. So you plug in 0. Right there we'll just have minus 4 on top. Okay? Negative 4 on top. Plug in 0 for x here we have 1 times 0 here we'll be having negative 3. Okay, this makes a lot of sense because negative 4 is on top and negative 3 is at the bottom. So we just have positive 4 over 3. That is greater than 0. So that means that this part satisfies the inequality. Alright? So between -1 and 3 over 2 is going to be taken. Okay, so we apply the same thing here. We're going to have 3 over 2, between 3 over 2 and 4. Let's pick, 3 over 2 is like 1.5, so let's pick 2, okay? If you pick 2 from there and plug in place of x here, we'll be having 2 minus 4, that is -2, and at the bottom, we'll be having 2 plus 1, that is 3, and again, we'll be having 2 times 2, that will be 4 minus 1, minus 3, that is 1. So we'll be having -2 over 3, which is less than 0. So again, this interval does not satisfy what we want. So the last, we just pick 5, okay? So we plug in 5 here, we're going to have 1 in the numerator. So we have, plug in 5 here, we're going to have 6 here. And on this other hand, we'll be having 5 times 2, which is 10, minus 3, which is going to give us 7. So at the top, we'll be having 1 divided by 7. In fact, that interval right there satisfies what we want. Okay, so that makes a lot of sense. So the interval that totally as a result is going to be from -1 to 3 over 2. Now I'm using this normal bracket, okay, as an open bracket. Open bracket, that means that the intervals or that the salient point, okay, these points -1 and 3 over 2 are not included because they would make our inequality to be -1, and this will make our inequality to be undefined by having 0 in the denominator. Okay, so we unite it with, we go again from 4 to infinity. So you see that 4 is excluded because it will make our inequality to be equal to 0. Okay, so that is the solution to that particular question. Okay, let's move over to the next question. And this is the third question we are having on the board, that if sine alpha is equal to 2 over 3, that we should find this expression, tangent of 45 degrees plus alpha divided by cosine square of alpha. So the first statement gave us something that we would use that will make the question a little bit easier, right? We have it that sine alpha is equal to 2 over 3. Okay. Now let's look at this on a right angle triangle. Of course, you know that if this is alpha as an angle, okay, then sine alpha will be, sine of an angle is going to be opposite to the angle divided by the hypotenuse side. So we are having 2 in the numerator and 3 in the denominator. So 2 is here and 3 is here, so that we have it to be that sine alpha is equal to 2 over 3. That means that, okay, so we know that already. Let me just clean it. Now, if the longest side and this side is 2 and 3, 3 and 2, that means that this other side will be square root of 3 square is 9 minus 2 square is 4 square. That is going to be 5. So you just take it out, okay, using your Pythagoras rule, that this other side is going to be root 5. All right, that is the square of the longest side minus the square of the opposite to the angle, then the square root of the result. Okay, so that is what you get. Now, after you've gotten the root 5, we would like to go ahead and say that cosine of alpha, which is always given as the adjacent side, that is root 5, over the hypotenuse side, that is 3. And we can also notice that tangent of alpha is going to become opposite to over adjacent root 5. So those are the things that we take note of, and from there we can just go ahead and plug them into this expression and we get what we want, right? Okay, now I believe you're conversant with the tangent of double angles, of two angles, of the sum of two angles. Okay, so by that identity, trigonometry identity, we're going to say that tangent of 45 degrees plus alpha is equal to tangent of 45 degrees plus tangent of alpha divided by 1 minus tangent 45 tangent alpha. Alright? You know, we just talked about tangent of the angle A plus tangent of angle B divided by 1 minus tangent A times tangent B. So we're just making use of the formula, okay? So we know tangent 45 degree to be, tangent of 45 degree is just equal to 1. It's one of the common trigonometric ratios. Okay, so we just put it down there, 1 plus tangent of alpha from what we've gotten is equal to 2 over root 5. So we just put it down, 2 over root 5. Again, in the denominator we put it down 1 minus tangent of 45 degrees is just 1. Then tangent of alpha again is 2 over root 5. That is just 2 over root 5. So multiplying it with 1, it still remains 2 over root 5, okay? So from here, let me just put it down on top. This will become 1 plus, let me just write it again, 2 over root 5, okay? 2 over root 5 divided by 1 minus 2 over root 5. So if I multiply root 5 on the top and the bottom, I'm going to cancel some things. This will give us, just multiply the top and bottom by square root of 5. Okay, so this will give us root 5 plus 2 divided by root 5 minus 2. Okay, well, I can still go ahead and multiply the top and bottom again by still the same root 5, or just to do some things, but this could also be a nice place to pause. Okay, let me just stop here and see some things. Let's say that is tangent of 45 degrees plus alpha. So that is it, okay? So the next thing we have is the denominator, which is cosine of square alpha. So we have seen cosine alpha to be root 5 over 3. That means that cosine of square of alpha will now become just the square of root 5 over 3. Okay, so we square that. We're going to have 5 over 9. That means the denominator is just 5 over 9, okay? So that simply means that tangent of 45 degrees plus alpha divided by cosine of square of alpha is going to be root 5 plus 2 divided by root 5 minus 2. Then the denominator was 5 over 9. 5 over 9. So we just identify this as division of fractions, and we can switch the denominator, and this will take us to just having root 5 plus 2, then this will come down, this will go up, times 9 divided by root 5 minus 2, again, times 5. Okay, so we just multiply everything throughout. I will have 9 root 5 plus 9 times 2 is just 18 divided by 5 root 5 minus 10. I'm just writing minus 2. Okay, that's minus 10. So this could be a nice place to stop. Yeah. This is a nice place to stop. Or even if you want to multiply root 5 over 2 again, top and bottom, let me just see what we can get. This will also give us 9 root 5 times root 5 is just 9 times 5, that is 45. Plus 18 times root 5 divided by 5 root 5 times root 5 is just 5 times 5, that is 25. Okay? So 5 times 5 is 25, then minus 10 root 5. So we can stop there, but if you still want to go further, you can still go further, but that's a nice place to stop, right? So that's just the number 3. Okay, let's move over to the fourth question. Alright, this is the fourth question. We have to evaluate without using tables or calculator. I didn't state that, okay? Tangent of 75 degrees. Okay, let's do this real quick. You know that 75 from our basic addition and subtraction, you know that 75 can be gotten from 40 plus 30, okay? And I'm using 40 plus 30 because 40 and 30 are some common trigonometric. We have some trig ratios for them, okay? Known ones. Okay, so I'm going to be using 30 plus 40. So I'm going to rewrite this as tangent of 45, not 40, 45 plus 30 degrees. So this will add up to 75 degrees, okay? Okay, so from here we just notice that when we have tangent of the sum of two different angles, I'm giving them AB, that this is just equal to tangent of A plus tangent of B, right, divided by 1 minus tangent of A times tangent of B. So when we have the sum, it's going to be plus here and minus here. Then when we have the difference, here is minus, we're going to be having, let me just put it down. When we have minus here, this place will be the minus, while this place will be the plus, right? Okay, that's just for next time, right? Okay, so I'm going to apply this. This could be our A, so this could be our B. So let A be 45 degrees and B be 30 degrees. So that means that I'll just put everything down. Tangent of 45 degrees plus 30 degrees will be equal to tangent A, that is just tangent 45, alright, plus tangent of 30 divided by 1 minus tangent 45 times tangent of 30 degrees. So without the degrees, you just know that they are angles, alright? Okay, so we need to know what's our tangent of 45 degrees, and we also need to know what our tangent of 30 degrees. Well, for a little reminder, okay, let me just check them out. When we have an equilateral triangle, let's say where the length of all sides are 2, so let's divide this into 2 equal parts, alright? So this is going to be 1 and 1. Okay, let this be our angle. Let this be 60 degrees, and this other one 30 degrees. This is the right angle at that point. So that means when we are considering the angle 30 degrees here, we'll be talking about this will be 2, this will be 1. Then this side will be 2 square minus 1 square, that will be 3. So the square root of that is just root 3. So tangent of this angle 30 degrees is going to be opposite divided by adjacent. So tangent of 30 degrees will be 1 over root 3, alright? We can also do the same thing for the 45 degrees. 45 degrees, I'm going to be making use of a square, okay? I'm going to divide that. I know that line is a diagonal and crosses at the center. So this was 90 degrees. That originally was 90 degrees, but since I've divided into 2 equal parts, we're going to be having 45 degrees here and also 45 degrees here. So maybe this was of length 2 throughout. Okay, let's call it length 1, since I'm not going to divide anything. Okay, so that will be length 1 throughout. So we can talk about the longest side, which will be 1, 1. Then this side will just be the squares, sum of squares of these other two sides. So that will be 1 square plus 1 square, that will be 2. That will be 1 plus 1, that is just 2. So square root of 2, alright, so if we are considering this is 45 degrees, even this part as well. So tangent will be opposite over adjacent, that is 1, okay? So that means that tangent of 45 degrees is equal to 1. So that and from here, just know that tangent of 60 degrees will be root 3. Right. So we can just plug those things in here. We're going to have tangent of 45 degrees to be 1, tangent of 30 degrees to be 1 over root 3, then divided by 1 minus tangent of 45 degrees is just 1, times tangent of 30 degrees, again, is 1 over root 3. Okay, so we just go ahead and simplify some things. So from here we can enter with root 3 plus 1 divided by root 3 minus 1. That is what we get, okay? I'm just doing that by taking the LCM of the numerator and denominator. Okay, well, since that was the only question, so that is a nice place to stop. We can just write it as root 3 plus 1 divided by root 3 minus 1. Well, if your lecturer requires you to go ahead and let's say multiply to a bottom by root 3 or the conjugate of the denominator, you just do that and simplify things, but that's a nice place to stop. Okay, let's see what's the next question, number 5. Okay, number 5, let's clean the board and answer the next question. Now right here, we want to solve for the number 5, that we should evaluate sine of 52.5 degree times 7.5 degree without using table or calculator. Now, well, we have to evaluate the product of sine functions of different angles, and we are not to use the table or calculators. And looking at those angles, they are not the common angles that we know of. They are sine and cosine functions. So, how do we go ahead and evaluate this? Well, when we have the sine of an angle multiplied with the sine of another angle, this has an identity. So the trig identity for this is just equal to 1 over 2 times now cosine of the first angle minus the second angle, A minus B, minus, then the next thing is cosine of A plus B. So this is how it is being represented. So 1 over 2 of cosine of the first angle minus second angle minus cosine of the first angle plus the second angle, that is the same thing as the product of sine functions of different angles. Okay, and when they are told like that. So that is what we are just going to make use of, and we will go ahead and see what you get. Okay, so from here, I will just know that A is 52.5 degree and B is 7.5 degree. That means that sine of 52.5 degree times sine of 7.5 degree will be equal to 1 over 2 of the cosine of their difference. So 52.5 minus 7.5, that is very simple to calculate, okay? That is just going to give us 45 degree. So we go ahead and put it down, 45 degree. Again, we minus it with cosine of, now the sum of these two angles, 52.5 and 7.5 will give us 60 degree. Okay, so just put it down, 60 degree, and that is it. Now here, 45 degree and 60 degree, they are common, we have their common ratios, okay? So when we talk about cosine of 45 degree, that is just root 2 over 2. So we just put it down, 1 over 2 times root 2 over 2 minus, now cosine of 60 degree is the same as sine of 30 degree, so that is just 1 over 2. So cosine of 60 degree is 1 over 2. So from here we can just go ahead and, well, we see that 1 over 2 is common in the bracket, so we can take it out. We're going to have 1 over 2 times this 1 over 2, that will become 1 over 4, and inside the bracket we just have root 2 minus 1. And this is a nice place to stop. So this is the result. Okay, that was pretty simple though, and a little bit tricky. So the only trick there is to know how to substitute this for that. Every other thing is taken care of. Okay, let's move over to the 6th question. Now right here on the board, we want to find the coefficient of x squared in the expansion of 1 minus 3x all raised to the power of 7. So this is just a binomial expansion question. Yeah, so we have to, the question means that we should find the coefficient of the term containing x squared in the expansion of this. So after expanding, you have a series, then you check each of the term in the series, then the term that has x squared. So what is the coefficient of the term that contains x squared in this binomial series? Well, how to tackle this question is just by considering the power 2, that is, to make it square, okay? So when we consider the power 2, we are going to equate a certain term we are going to equate a power of a certain term to power 2. So we're going to get the term that will give us that. Now, this is what I mean. We know that the rth plus 1 term of a binomial series is denoted by NCR, okay? Then the first term here, which is 1 raised to the power of n minus r, then times the second term, which is negative 3x raised to the power of r. So in this case, 7 is the n, right? Very nice. And r here is what we're choosing, that is from the combinatorial analysis. So when we want to consider the term with the power 2, that is the term containing x squared, we are going to consider the power of this r plus 1 term. That is going to be, this is just 1 raised to the power of 7 minus r, and this is just negative 3x raised to the power of r. This is just nc, this is 7cr, okay? Alright, so the power of x on the left hand side here, you know, this one has no x in it. So the power of x on the left hand side here is just going to be negative, this is negative 3r, it's just going to be r, alright, by opening this bracket. So that means that for this term to contain x to the power 2, r should be 2. So we just equate that r to 2. That is the basic idea, alright. Just get a certain term. Generally, we write it as this. Then, for the power of x in this term to be 2, you just try to expand the first term in case this first term also has an x, and also for the second term. Then you equate the power of x, alright, in this to 2, okay, if 2 is needed. So by doing that, this man here is independent of x. So it has no x in there, but this one has an x. So by raising it to power r for any r, then 3 has it and x has it. So for this term generally to contain the x squared, then the power of x here should be 2, right? So that means that the r is equal to 2. So if r is 2, then we are talking about the third term. That is 7c2, then 1 raised to the power of 7 minus 2, then negative 3x raised to the power of 2. So by expanding this, then the coefficient of x squared is the result. So we're going to talk about 7c2 is just like saying 7 factorial over 7 minus 2 factorial, then 2 factorial. Then 1 raised to the power of 5 is just 1, right? So, and 1 multiple doesn't change anything. Now, this is negative 3 raised to the power of 2, and this is the x squared. So, this part, alright, of this expression is the coefficient of the x squared. So, all we need to do is to try to reduce this a little bit, and we keep that as a result. Okay, so let me just try to do that real quick. This will be 7 times 6 times 5 factorial on top. That is from 7 factorial, right? And on the bottom, we'll be having 5 factorial, okay, times 2 factorial. And here we are talking about negative 3 raised to the power of 2. That is just 9. So that is the coefficient of the x squared. Now we see that 5 factorial and this other 5 factorial will cancel. So that is why I actually stopped there. And again, we are going to have 2 here. 2 factorial is just 2, right? So 6 divided by 2 is going to give us 3. So we'll be talking about 7 times 3 times 9. Alright? So looking at this, well, 7 times 9 is 63. So 63 times 3 is going to give us 189. So 189, you know, if this x squared was following us, we'll just be putting it down. X squared, x squared, x squared. So the coefficient of x squared here is 189, and that is it. Alright, so how do you even know that term? You just use this general form, okay, this r plus 1 term of the series of a binomial series, okay, to get the term. Now this is generally, then the particular term that will have x to the power 2 is when we equate the power of x in this particular term to the 2. Okay, so if you were to ask to find the coefficient of x to the power 3, you will equate the power of x in this particular term. So you see that the first part of this term does not have any x in it. So the power of x there will be 0. We don't need it. But this second part has an x in it, and the power of x there is going to be r. So you equate it to 2. Okay, like this is r. I equated it to 2. So by equating it to 2, that gives you your r, and if you plug in r back here together with your n, you can get that particular term that will give you x squared, and the coefficient is what is needed. Okay, thanks for watching, and we're going to move over to the 7th question. We want to find the square root of 19 minus 6 root 2. Well, when we want to find the square root of a solid expression like this one, the first thing we're going to look at is this sign in front of the radical term, that is the minus or is plus. So that will determine the nature of the square root. So in this case, we are going to assume the square root to be, let me put it down this way. Assume that square root of 19 minus 6 root 2 is equal to root a minus root b. So if this was plus and not minus, then we will assume the square root to be root a plus root b. Alright, that's just by the way. And again, since this is negative, okay, you know that this is not commutative. That is, root a minus root b is not the same thing as root b minus root a. So because of that, we are really mindful of which one comes first, okay? And again, we want to get only the positive square root of this expression. That is to say, this right hand side should not be negative. That means that square root of a should be greater than the square root of b. So I'm saying this because when we solve for our values of a and b, we always enter with 2 values for a and 2 values for b. So one will tend to be bigger and the smaller. So we are going to choose values of a and b such that the value of a will be greater than the value of b, which will make their square roots to also follow the same inequality. Alright, so knowing this, let's just go ahead and try to solve this. Alright, so I'm going to start by putting down the square root of 19 minus 6 root 2 to be equal to square root of a minus the square root of b. So from here, I see that if I go ahead and square both sides, right, I raise both sides to power 2, like this. The next thing I'm going to enter with is this square and the square root will just cancel out nicely, and we are going to go ahead and have 19 minus 6 root 2 on the left hand side. Then on this right hand side, we're going to have square root of a squared minus 2 times square root of a times square root of b, then plus the negative square root of b, and we're going to go ahead and square that. Okay, so that's just it. Now from here, we just have to talk about square root of a squared is going to leave us with just a, then negative of 2 times, we are talking about square root and another square root being multiplied together, okay? So we just have the square root of the product of the numbers, right? Plus, so this is square, so the square is going to take care of the negative, alright? And square root of b squared is just going to be b. This is just 19 minus that. Alright, so this is the next thing we're going to talk about. Let me just put it down. 19 minus 6 root 2. So the next thing we'd like to talk about here is the radicand terms and the non-radical terms. What I mean is 19 is just on its own, okay? It is just a rational number. But negative 6 root 2 is irrational. So we're going to equate the rational part to the rational part here and the irrational to the irrational part here. Alright, so that, considering that, we're going to have that 19 should be equal to a plus b, right? And the negative 6 root 2 should be equal to negative 2 root a times b. So that is what I mean. Alright, so from here we can just go ahead and call this equation 1 and this other one equation 2. So we're going to solve this equation 1 and equation 2 simultaneously for the values of a and b. Alright. Now from equation 1, we see that a is equal to 19 minus b. So we just keep that and we're going to use a substitute for the equation 2. So we're going to enter with negative 3 root 2 is equal to, 3 root 2 is equal to root of ab. Right? That is just by dividing both sides by negative 3. Okay, so the next thing I'd like to do here is just to multiply both sides or to square both sides here. So from here, if I just square both sides, we will see that we will have 9 times 2 is equals to AB. That means that 18 is equal to AB. So from equation 1, we had that A is equals to 19 minus B. So let's just solve that real quick. We're going to have 19 minus B times B. Okay, so by solving this further, we're going to see that B squared plus 19 minus 18 plus 18 equals to 0. This is minus, right? Okay, so from there, we can just go ahead and solve for the two values of B because this has led us to having a quadratic equation. Alright, so by solving for the two values of B, I would like to use factorization method for this. Let me see. If we have, this is 18, so if you're talking about 6 and 3, no. Okay, negative 18 and negative 1, alright? So we're going to have b minus 18 and b minus 1 will be equal to 0. That means that b equals to 18 or b is equal to 1. Okay, so when b is equal to 18, what will we have as our a? From this equation we had from equation 1, we will see that a will become 19 minus b, so a will become 19 minus 18, which is 1. And again, when b is 1, a will become 19 minus b, which is just 18. Alright, so we've successfully solved for the values of a and b. Now is the deal. Or now we are going to apply this fact. So when b is 18, a will be 1, meaning that a is going to be smaller than b. But we didn't want that. So we're going to take this other one, that when b is 1, a will be 18. So because of that, we're going to finally put it that a is equal to 18 and b is equal to 1. So that the square root of 19 minus 6 root 2 will now become square root of 18 minus square root of 1. And the square root of 18 is just 3 root 2, then square root of 1 is just 1, and this right here is the square root of 19 minus 6 root 2. Okay, so if you were to consider the other negative root, that will just be by taking b to be the bigger number and a to be the smaller one. That means we were going to have square root of 1 minus square root of 18. That will be 1 minus 3 root 2. Well, it's still going to give us the same thing, okay? But once we are looking for the positive square root, we consider root a to be greater than root b. Alright, that was a very nice question. Alright, let's move over to the 8th question. This number 8 question, we want to find the values of x that satisfy the equation, the logarithm of 3x plus 1 to base 6 equal to the logarithm of 3x minus 1 to base root 6. This is very simple, but it's a little bit plenty, okay? Now, on the right-hand side, I'm going to have to do a change of base of logarithm because this base root 6, I want to get 6 out of it, all right? And this is how to change the base. First of all, you are going to write it as a quotient, so you just know that. Then at the top, you're going to put down logarithm of, now, 3x minus 1. So by change of base, we want to change the base from what we have to what we want to have. So I'm going to change the base from this root 6 to 6, all right? So I'm going to change that. Now, what am I going to write in the denominator? Well, this is it. Still base 6, okay, the new base. So the other base, the primitive base now, that is the root 6, I'm going to put it down as a number in the denominator. So I'm simply saying that the logarithm of 3x minus 1 to base root 6 is the same thing as the logarithm of 3x minus 1 to a new base 6 divided by logarithm of root 6, that is the other base, still to the new base. Okay, so that's just it. And on the left hand side, I still put down 3x plus 1 and then base 6. Alright, okay, so this is another thing we're going to consider. I'll just write down the base 6 here, 3x plus 1, base 6. And on this right hand side, I'm going to write the logarithm of 3x minus 1, then divided by the logarithm of 6 to power 1 over 2 to base 6. You know that the same things, alright? Square root of 6 is just like saying 6 raised to power 1 over 2. Okay. Well, and you know that it is still correct. As I've written the 1 over 2 here, I can still take it down here and put it in front as a constant multiple. Alright? So that is just what I'm going to do. And that means we're going to have, this implies that logarithm of 3x minus plus 1 to base 6 is the same thing as the logarithm of 3x minus 1 to base 6, all divided by 1 over 2 times the logarithm of 6 to base 6. And you know that the logarithm of a number to the same number as a base is going to give us 1. So we'll just enter with 1 over 2 in the denominator, right? Okay, or better still, let me just go ahead and multiply the top and bottom by 2. Okay, I just want to get rid of the 1 over 2 at once. So from there we are going to have that the logarithm of 3x plus 1 to base 6 is equal to 2 times the logarithm of 3x minus 1 to base 6 divided by 1. Why? 2 times 1 over 2 is going to give us 1. And again, logarithm of 6 to base 6 is just going to give us 1. So the denominator right there is just 1. Okay, so the next thing here is to look at this as 3x plus 1, and here, all these brackets, and on the right hand side as the logarithm of 3x minus 1 to base 6, and I just square that. That is, I bring the 2 upward again. So this simply means that when we have logarithm of 3x plus 1 to base 6 equals the logarithm of this to root 6, is the same thing as squaring this and taking the square root from there. Alright, so again, I'm going to see that this logarithm to the base, if I take the anti-logarithm of base 6 to both sides, okay, or if I make 6 the base of both sides, I'm going to have 3x plus 1 is equal to 3x minus 1 or raised to the power 2. Right? Then again, if we can expand the right hand side, we're going to have 9x squared minus 6x plus 1 then is equals to 3x plus 1. Okay, that still helps us. And now, well, we've arrived at a quadratic equation, so let's just try and deal with it. So this is 9x squared minus 9x equals to 0. So here we can just factor x to the left-hand side. Okay, we're going to have, in fact, let me just factor 9x instead of just factoring only x. Well, it's still the same thing. Factor 9x, I'm going to have x minus 1 equals to 0. So we had the product of two terms giving us 0. It means that at least one of them will be 0. That is to say that, okay, that is 9x equals to 0, or x minus 1 is equal to 0. So here we have that x is equal to 0 or x is equal to 1. So with these values of x, that equation will be satisfied. Okay, that was the 8th question. All right, let's move on to the next question. Now here on the board, we want to answer the number 9th question, that if the third term of a GP is 7 and the fifth term is 112, that we should find the nth term. Well, we know the nth term of a GP, it is given as, right, where A is the first term, R is the common ratio. Then n minus 1 is just 1 minus, like you take away 1 from the term you are asked to consider. Okay, so here we are given that the third term is 7 and the fifth term is 112. Then you should find an nth term. That is, you should use the given information to produce a general term for any n. Okay, right. So we will be talking about the third term. So when we have the third term of a GP, it is given as AR raised to the power of 3 minus 1. That is AR raised to the power of 2. And the fifth term is also given as AR raised to the power of 4 minus 1, which is just AR. Sorry, this is 3 minus 1, 5 minus 1. So that will be AR raised to the power of 4. So the third term is said to be equal to 7. So we equate this to 7. And the fifth term is said to be equal to 112. So we equate that to 112 like that, alright? Okay, so this simply means, let me just put it out, that AR raised to the power of 2 is equal to 7 and AR raised to the power of 4 is equal to 112. So we can call this our equation 1 and 2. Alright. Okay, this is A, not 9. A. Alright, so from here we can try to get the values of the A and the R. So we can get that by, let's just go ahead and divide equation 2 by equation 1. Okay, so from here we will talk about this divided by that. So you will see that the A and the A will cancel and we'll just enter with R raised to the power of 4 divided by R raised to the power 2 equals to 112 divided by 7. Okay, so R raised to the power of 4 divided by R raised to the power 2, we know about our indices, so we're going to have R raised to the power 2 as a result. Then 112 divided by 7, well, that will just give us 16, alright? So we just have it there, 16. So the value of R is going to be just 4. Yeah. Okay, so we have that to be the value of R, and we can plug that in into any of these equations to get our value of A. So let's say, if you substitute, let me just use this part to solve for that. Substitute R equals to 4 into 1. Right? If you do that into 1, we're going to have A times 4 raised to the power of 2 is equal to 7. That means that A will be equal to 7 divided by 16. So this was for our R, and this is now for the A value. That is the first term, A, and the common ratio R. Okay, so for any n, this implies that Tn will now become A R raised to the power of n minus 1. That means 7 over 16 times R, where R is 4, So let me just put it down. Times 4 raised to the power of n minus 1. That is just it, alright? Well, we can rewrite that as 7 times 4 raised to the power of negative 2, that is in place of 16, then times 4 raised to the power of n minus 1. Again, we can also write this as 7 times 4 raised to the power of n minus 1 minus 2, that is n minus 3. Or we can even rewrite this as 7 times 2 raised to the power of 2n minus 6. Any of these could be taken, right? Okay, so that is just it, but it's correct. Alright, let's move over to the next question. We are given that t minus 2 and t plus 1 are factors of this polynomial where a and b are constant. Then we are asked to find a minus 5b. So first of all, we are to find the values of a and b, then we use that to compute this equation here, a minus 5b. Now, what does it mean for a polynomial to divide another polynomial? Okay, if t minus 2 divides this cubic polynomial, it means that if we use t minus 2 to divide this cubic polynomial, the remainder is going to be 0. That means that t minus 2 is a factor of that bigger polynomial. The same thing with the t plus 1. It is a factor of that bigger polynomial because it divides the bigger polynomial. Alright? That is to say, the remainder after division is going to be 0. And that also means that t equals to 2 is a solution to at cubed plus bt squared plus t minus 2 equals to 0. Okay, from the factor, that is from t minus 2 as a factor. Also, t plus 1 as a factor, it means that t is equal to negative 1 is a solution to still the same polynomial function plus bt squared plus t minus 2 equals to 0. Right. That means that if you plug 2 into this polynomial, the polynomial will be satisfied. And if you also plug negative 1 for t in this, it will also be satisfied. That is to say, the left-hand side will become 0, which is the right-hand side. So the idea I'm going to use here is to just substitute 2 for this and substitute negative 1 in place of t in this one as well. And we are going to simplify things. And from there, we're going to have 2 different equations so we can solve for our values of a and b. Alright? That is pretty simple. Okay, so I can go ahead and make this, maybe let me just make this equation 1 so that I will know how to refer to it. Equation 2, this is 2, and this is 1. Okay, so let's go ahead and solve that. From equation 1, I'll be talking about t to be equal to 2, alright? So I'll just plug in 2 for t. That will be a times t, 2 raised to the power of 3 is going to be 8. Then plus b times 2 raised to the power of 2 is going to be 4. Then plus 2 minus 2 is going to be 0. So we just go ahead and equate that to 0. This, let's call this our equation 3. And I can also do that to the next one. That from equation 2, we can have it that when we plug in negative 1 for t in this equation 2, we're going to have negative 1 raised to the power of 3 is going to give us negative 1. That is just negative a. Then plus negative 1 raised to the power of 2 become positive 1. You multiply that b, that's just b. Multiply that with b, that's just b. Here we're going to have negative 1 minus 2. That will be negative 3 equal to 0. So we can call that the equation 4. Right? Okay, that makes sense. So from equation 4, from equation 4, you will see that from 4 you can see that A is equal to, or let me make B equals to 3 plus A. That is just by just making the subject the formula. That will be by adding A plus 3 to both sides. Okay, so A plus 3 or 3 plus A is commutative. From equation 4 we can have that for B. So we substitute, I would say substitute B equals to 3 plus A into equation 3, right? So we're going to make that substitution, and we're going to have 8A plus 4 times B, where B is 3 plus A equals to 0. So from here we're going to have that 8A plus 12 plus 4A is equal to 0. So from here we're going to have that A is just equal to, we have this 12A minus 12, that is just negative 1. So we have the value of A to be negative 1. And, well, if we go ahead and try for B, what are we going to have? Well, since B is equal to 3 plus 8, means that B will be equals to 2, alright? So that means that, all in all, A minus 5B will be equal to negative 1 minus 5 times 2, right? That will become negative 11. And this is the answer to the question. But the most important thing was to find the values of A and B first. Then you just make use of that and answer what you're being told to find. Okay, that's a nice place to stop. And this last question, number 10, will end the first part of our solutions to 2009 and 2010 past questions of Maths 111. So get ready for the second part. In fact, we'll move over to the part 2.